Right. Hello, everyone. My name is Colin Sauze. I'm a senior research software engineer at the National Geography Centre, and with me is Sadie. Do you want to introduce yourself?
Yes, sure. Hi, I'm Sadie Bartholomew. I work for the National Centre for Atmospheric Science and the University of Reading.
And we're going to just do a bit of a presentation, then have some discussion, and then a bit of demonstration about some green software development principles, patterns, and practices. So this is trying to create some sort of practical actions that maybe we can do day to day in the software we develop that might help to understand and reduce the climate impacts that we're having. So just to sort of set out what we're going to talk about first is a very broad definition of what we mean by green software. Then we're going to look at some metrics about how we can measure that impact and how we might calculate those things, look at some tools that will help us do that, then go and look at some design patterns that are designed to reduce those impacts and some general best practice, show you some useful resources. Then we've got a bit of a discussion session about how we might translate some of these things which haven't developed in our community, have developed in the sort of the wider software development community, back to the research software community. And then finally, we've got a demonstration which you can try and follow along if you meet some of the system requirements that I'll talk about later, of using the Firefox Power Profiler to very accurately power profile an application and see what bits of your application are actually using energy. Okay, so hand over to Sadie for the next bit.
Thank you, Colin. So I'll go on to introduce the main concepts. Okay, so oh yeah, sorry. So helps to start by defining green software. Obviously, by green we don't mean the color green. We mean as in eco-friendly. So ultimately, as we define it specifically, we're talking about software which is part of the solution and not the cause, and specifically with regards to greenhouse gases and their emissions. So ultimately, we want to be reducing the amount of emissions rather than increasing the amount that get released. And there's three main ways in which this can be achieved, at least according to the classification by green algorithms and others. So the first is using fewer resources. So by resources, we in particular mean hardware, so kind of physical resource. So making less new hardware, trying to reuse more hardware that we already have. Secondly, using less energy. So obviously, when you use software, it needs energy to ultimately run. And if you can make it more efficient, it'll use less electricity. And finally, using energy more intelligently. So as well as trying to use less, if we try and use it more intelligently, we can reduce our use of or release of greenhouse gases ultimately. So intelligent use of energy might be where we're using more renewables instead of more dirty energy, say more coal. And renewable energy is more plentiful at certain times and dates, which we'll go on to talk about.
Places.
And places, yes. Get that, sorry. Um, so how specifically can we measure the impact of software? We actually have a equation which provides this metric, the software carbon intensity, or SCI. Shall I acronize that from now on, or yeah, well, so we'll call it SCI. And this is an equation that hopefully isn't too complicated. So I guess four variables here. E is the energy in kilowatt hours. This is multiplied by I, the energy carbon intensity, with a unit that's quite compound here. It's this here stands for grams of carbon dioxide equivalent per kilowatt hour. Am I saying that right? So by equivalent, we are referring to the fact that different greenhouse gases have different impact on climate. I'm actually past to Colin here.
Okay. So there are greenhouse gases that have more warming impact on the Earth's climate than others. So for instance, methane is about 5 times what carbon dioxide is. So if we emit 0.2 grams of methane, that is the same as 1 gram of carbon dioxide. So if we had a gas power station that, say, for every gram of carbon dioxide it was kicking out, was also kicking out 0.2 grams of methane in wasted gas, that would count as a score of 2 on that.
Thank you. Yeah, so basically it standardizes the gases.
I'm not sure what the time span is.
Okay, yeah, what Loic said. Yeah, so that's I, the energy carbon intensity. Obviously, we already use an E for energy, so when you remember it, remember the I is for the intensity there. So you add on to that M per R, where M is the embodied carbon from manufacturing, or maybe the M stands for manufacturing, I'm not sure. Probably more the embodied. Again, we'd want to use E, but it's would have been used already twice. And R is this functional unit. So this is referring to per the user or per the device or per the API request, per whatever is the appropriate unit that you're wanting to consider. So the full equation, and remember this, I feel like, oh, there is a whiteboard. Maybe I can write it down because we're going to go on to cover these variables in more depth. Is that the software carbon intensity metric? Yeah, I'll try and write and talk at the same time. The SCI is E multiplied by I plus M per R. See if this works. And that is a metric to measure the impact of software. So we'll go on to see how this works in a bit more detail. So let's start with the energy component. Though actually, I will maybe write that down just in case I write it down wrongly. So the SCI is the E multiplied by the I, that's the intensity, plus the M. Are we writing per R? So the embodied carbon per functional unit. Okay. So starting with the energy, which is the E in our equation. So this is in kilowatt hours. So for example, if you're running a computer, it's the power consumed by it multiplied by the time taken. The standard unit is taken as an hour for historical reasons. I'm not quite sure why.
Billing reasons.
And billing reasons, yeah, exactly. So a question to consider is, do you want to think about the whole computer or just say the jobs or the process that is running the software in question? I guess it depends on the context as to which of those two you go for. And there's also things such as the RAM, the random access memory, the disk, and the network. So there's a lot of different things to consider when we're thinking about the energy. And another thing that maybe isn't something you'd immediately think of is cooling for the data center. So with software, you're often using data, or in most cases, if not all, and that has to be processed and stored somewhere. At least this is not if you're not doing this on your laptop or locally. Now, most data centers have this concept called the PUE, which stands for the power usage efficiency, which is a rating that tries to classify the cooling to compute ratio. So if this ratio was 1.0, that would be perfect, which I think is inachievable.
That means you're using no cooling. So you
totally
passive cooling system.
So I guess everything would just overheat, right?
Yeah, that's what to say. In Iceland, and you had cold air blowing in naturally. Yeah.
Okay. So moving to Iceland is a solution. So apparently typical, I say apparently because this is quite new to me, this particular bit. Apparently a typical value is between 1.2 and 1.4. Do you know what a bad value would be? Could something be as high as 2 or 10 or 100? This is an open question to anyone that knows more.
2-ish.
2-ish? Yeah, fair. So.
Is that a question?
Yeah, I feel that thing that people sort of use combined heat power, they use that waste heat for other uses such as
I've heard about some ideas about using that waste heat for other purposes, such as like heating community swimming pools. Could that factor into that? So if that heat has another purpose, would you reduce that to being closer to 1?
Yeah, I think you would. How you exactly account for that might be difficult because those things probably don't use that heat perfectly either. And that's probably a great way of making really muddled statistics. And I do worry slightly that some of the commercial providers might try and do that as a way of greenwashing themselves. I think Loic wants to say something as well.
They're already doing it.
Already using it, already greenwashing over it.
Both. The So the PUE, the one that's reported is usually the design one. So when they build a data center, that's like the ideal PUE, and that takes into account any kind of mitigation measure, like plugging the heat exhaust to the swimming pool or whatever. And it's also different from the actual PUE of, which depends on how much equipment is in there. And so they're already accounting for it, probably too much, but it can help. What's interesting about the PUE is it works specifically if it's by design. Usually trying to retrofit a data center doesn't work really well, I think.
Don't drop your data center in the swimming pool after you built it. Yeah, no.
Great. So yeah, that was just a little discussion about power or conversation about the power usage efficiency rating for data centers. And so finally, we'll talk a little bit about some data tools that can actually help with your energy usage in a bit in the slide. Hopefully that's all fairly clear. So moving on to the energy carbon intensity, which is the I in the equation. So in the UK, but probably around the world as well, the power grid really varies in how clean the grid is at any point in time. So in particular, in terms of carbon intensity, it's very variable depending on the time, date, place, as Colin pointed out before. So we've actually got a plot here which kind of demonstrates, I think this is over time. Where specifically is that one? Is this... Oh, it's different areas nationally. I see. Okay. Fair. Yes. You can actually see from the table, the text is potentially a little bit small, but it's kind of classified the carbon intensity as between very low or very high, according to a couple of levels: low, intermediate, high. And you can actually see that depending on the area, it can vary from very low to very high. And that's for a specific time, I think. But we'll go on to show some examples of how a specific time on different days with different conditions, it can vary from time to place, from place to place, sorry. In general, when it's sunnier and when it's windier, the carbon intensity will be lower. So imagine that means that we can use, if it's sunnier, we can use solar power. If it's windier, we can use wind farm energy, which means that carbon intensity will be lower. And if it's the opposite of that, so if it's cold, if it's dark, the intensity will be higher. So some typical values for a low carbon intensity are less than 50 of this unit that we mentioned before, the grams per carbon dioxide equivalent per kilowatt hour, which is a bit of a mouthful. So I might avoid saying it again, but that's the unit we generally work with. And above 400 would be high typically. So we're going to show some examples which hopefully can put that into context. But graphs such as that from, you can actually get them live from certain websites. So there's the carbonintensity.org.uk for the UK power grid. And the national grid have some resources as well. So there's a few URLs that I won't read out in full, but are on the slide there. Good news is that actually the power grid is getting greener over time. So we've got a visualization here just showing a kind of historical trends. So hopefully you can just about read the axes, but the first row is 2009. Final row is 2024. As you can see, obviously we've only been third of the, so there's only a third of the information there. But the darker the squares, the higher the carbon intensity in general. So you can see there's a general pattern that as the years go by, things are getting lower in terms of carbon intensity, and there'll be seasonal patterns and things like that as well that could be picked out, but I won't go into detail on those. So that's good news, and it means that we're using less kind of dirty energy, less coal, and more renewables. Just some examples, statistics that Colin's picked out. Between 400 and 600, which remember we classified as high, I think was the average across 2009. And then last year, the average was, or sorry, not the average, the range was between 60 and 200. So that's pretty good, I think. In terms of becoming net zero, which is obviously quite a lofty challenge, but a lot of governments, or at least organizations, are committed to try and doing this. It does rely on obviously carbon capture and storage, because you need some way of, you can be as efficient as you want, but you need some way to offset what you do use.
You've still got to burn some gas on the days where it's not windy and sunny. So there will be, even when we hit so-called net zero, that is achieved by occasionally burning natural gas and capturing the carbon from that. That is in the current plans. Maybe one day we will not have to do that, but that is our current plan. But from next year, we should at least see some periods where we have enough battery storage on the grid to actually hit 0 grams equivalent per kilowatt hour, but it won't be anywhere near all the time.
Yeah, sorry, Colin knows a lot more on this bit about me than I do. But no, I think that's really promising. Sorry, I've skipped several slides somehow there. Yes, okay, this is the next slide. So just to have some examples here, and also to point out regional differences. So most of the offshore wind farm and renewable energy generation in wind that's offshore, so in the seas, is in Scotland, the northeast, northwest, and East Anglia, which is that. I'm not sure I can point it out there, but you see there's lots of different yellow circles there. That's the East Anglia area, I think, just about, or a little bit below. It's hard to see.
Yeah, that cluster there.
Yes, that's on the south east side of the country, of England in particular. Scotland has most of the onshore wind. Oh, sorry.
That one there is under construction, the big white circle.
Oh, this one here. Oh, that's, yeah, one that's really far out. Ah, nice. Sorry, yeah, I wasn't quite sure what the visualization was of, but
Potentially yellow is what it was doing on the day, but that visualization was captured. It's that website link.
Sure. Oh, I see. Okay, so there's an interactive map. Sorry, I should have pointed out of different wind farms, I believe. Oh yeah, it'd be good to see it live. Thanks, Colin. Any live demos never work, so we can might have to resort to the image. Oh, excellent. Yes, there's one very far offshore.
Yeah, so that's Dogger Bank, which is under construction. That's why it's got 0.
But yeah, I guess the more wind farms they're building, the better, really. And obviously, people consider them unsightly, so they might want them offshore, preferably. But
it's windier.
Oh well, that too. Okay, that's probably the more important reason. So Scotland has most of the onshore winds, so these are wind farms that are actually on the land. Solar works better in the south. Do you know why?
Sun's overhead.
Oh, of course. Yeah, okay. Should use my brain. So yeah, these are differences in kind of patterns of renewable energy. And we'll go on to some slides here that are just going to point out differences in carbon intensity. So this is an example from October last year, which was a day that was somewhat sunny, but very windy. So if you remember that windy, sunny days are great for renewable use. And just to point out some local differences in particular. So if we look at the map here, the colors, if hopefully you can just about read the key, but this darker green indicates a very low carbon intensity, and the lighter green low. And then the whole scale goes from this red for very high, orange high, yellow is a kind of moderate. But basically on this day, there was low and very low usage, with the low being in the south, and the very low in kind of these regions. So Wales, northeast, northwest of England, and the whole of Scotland. Some particular statistics on the slide here. In the south of England, I think this is an average, it was 92 grams per carbon dioxide equivalent kilowatt hour. And then in North Wales and Merseyside, it was just 4, which is very low indeed. So that was a good day in terms of renewables use. So on a bad day, in this case, it's less windy and less sunny, I guess. I guess the less applies to both. So that wasn't, I've already forgotten the date from the previous slide, the 6th, going to the 9th. So this is just 3 days later. And as you can see from the key that I mentioned before, same key where very high is this red that you can see is occurring in certain areas in the south of England. Even then, even on this bad day in Scotland, actually they're still doing pretty well in the northeast of England. Still had a very low carbon intensity. So particularly, oh What, in the northeast?
And in Norway, the black line there is the interconnect with Norway. So that all the black lines are interconnectors to other countries, so that these don't have infinite capacity. But I think to Norway, there's a couple of gigawatts now, and Norway's mostly hydropower. So that's why the northeast looks so good. But there's limited ability to then redistribute that through the rest of the UK.
Oh, interesting. Are those figures included out of interest in our power grid? Yeah. Okay, great. So it includes everything. So yeah, see, that was a bad day, but still there were some low and very low carbon intensities in certain regions, depending on kind of the distribution of various renewable use and factors like that. So just to pick out some bad carbon intensity statistics. So for that day, in the south of England, it was 289, and it was 235 in North Wales and Merseyside. Just you can see from the map is a mixture of orange for high and red for very high. Okay, on to embodied carbon now. So for our equation, that's the M. So if you remember my brief definition from the equation slide, this is emissions relating to the manufacture, the transportation, and the disposal. So kind of the life cycle of any embodied carbon in the, say, hardware. Another name for these is the scope 3 emissions. So this is naturally harder to measure than things like energy and energy intensity, because it covers entire supply chains and can cover different countries and different times. So it's a bit more complicated. Things like personal computers and mobiles often by far the highest emissions. Not sure about this figure, the lifetime emissions. Is that per computers and
compared to the energy the device would use during its lifetime versus what it took to manufacture and dispose of it, 75 to 85% is coming from that manufacturing and disposal process, and most of that is the manufacturing. But for a server, that won't be so bad because you run your servers normally 24/7, often at near max workload. Your mobile phone, your laptop actually sits idle much of the time and probably sits off or near off half the time.
Yeah, sorry, that makes sense to me. So it depends greatly on the usage of a particular device, but it's definitely something to be very wary of. Particularly, I've heard some discussions at this workshop about, it's good to reuse and replace things instead of just getting a new computer or mobile. So moving on to some tools to measure the impact. Sorry, is that on the frame? So there's some great resources out there in terms of measuring what impact you're having, because it's all very well for us to say, be aware that your work is having, effect on ultimately, it's releasing carbon and having an effect on the climate. But it helps to quantify that. And nothing's perfect, but there are some great resources that can help to quantify or estimate that in a decent way, perhaps a very good way, depending on the context. So the first to point out is green algorithms, which I believe was partially developed by Loic, who was in the room. So questions on that, he would be best to answer. So the link is there, and they have a calculator, which can actually provide some numbers, which, we could potentially show depending on time. I think we're all right for time. Yeah, we'll try and give a little demo. Yes, so this is the dashboard page for green algorithms.
Quick overview of it.
I don't want to put you on the spot. Okay.
Yeah, I mean, it's quite. Oh, sorry. Maybe reload it.
What's wrong with it there?
Well, there's no value in it. There should be some value. No, but you shouldn't have to. There should be some default. Oh. But anyway, it's quite straightforward. It's just you enter basic. So basically, the formula that was mentioned, it doesn't include manufacturing. So it's only just the carbon footprint from electricity usage the model. You just so basically it's like the lighter touch version. The other tools can be a bit more involved, a bit more accurate as well, depending on how they use. But yeah, you can just say the kind of hardware you have, and it will power usage, and then some metrics about the jobs, and you can kind of change the country, the location, and it gives some metrics. So it's quite basic and straightforward in theory.
Yeah, so this is the green algorithms dashboard with the URL linked to that there. Another tool we'd like to highlight is the Firefox Power Profiler. So we appreciate not everyone uses the Firefox browser, but it is a good example of a tool that, in our experience, is fairly simple to set up and can give some quite accurate. I'm not sure if it's an estimate or an actual calculation. I guess more of an estimate of the power that a particular browser tab, web thing is using. I'll not say too much because we're going to go on to do a demonstration of that. So CO2.js. So I guess this is a JavaScript app that estimates carbon emissions from transferring data over the web. Is that I guess that's just the name of it. There's no URL there, but just look that up if you want to find it. Oh, is it? Okay. Oh, so both a URL and a name. That's cool. For users of Linux, there's the PowerTop command, I guess, which again we might be able to show. So this is showing power usage of a Linux process, or probably all processes that are running on your local device. Hopefully we can do a live demo again. Yes. You usually have to use sudo for. Yeah, fair.
Security implications as well. But basically, that's got a power estimate for every process that's running on my laptop. So down the left-hand column, you see there's a watts number that's basically telling you what that is. And unsurprisingly, Zoom is actually using a large amount of my CPU and my power. And actually, the other day, I noticed that I had this running and Zoom was sat there idle. I wasn't in a call or anything. And Zoom was using something like 1 watt. And I quit Zoom and that went away. So don't leave Zoom open when you don't need to.
Some takeaway advice. Although we are on Zoom, so I shouldn't be too mean. It'll kick us out, maybe. Yeah, so that's PowerTop, and I believe there was 1 or 2 more recommendations we had. Yes, so the Linux kernel perf tool. So it's using a feature by Intel RAPL. You've heard of that? I actually haven't, but hopefully someone has. So that's measuring the processor power usage. So it's maybe quite similar to PowerTop. Oh, it is. Okay, fair. So maybe PowerTop essentially wraps that. Okay, thinking about the cloud is another consideration. Sometimes the cloud can be a bit of a black box. You send something to the cloud and things happen. And it actually can make it harder to get power usage information. So cloud providers do have climate targets, and often they sound very great and ambitious. But as to whether they will hold true on those, I'm not sure. Some are more forthcoming with their data, so some provide more data than others on this topic. So just thinking about some of the big players, Google, AWS, Azure, Oracle. So just some differences we've highlighted here in terms of what they do and don't publish. So remember this PUE is the power usage efficiency. Yes. So Google publish on a per data center basis. AWS don't publish at all, which is not good. Azure publish global averages, and Oracle state what the best one is. So in terms of intercomparison of those, they are all completely different things that can't be compared, which is maybe why they do it. I don't know. Another tool we'd like to highlight is this cloud carbon footprint tool. So specifically for cloud applications, you can estimate some emissions there. So it connects to, how it works, connects to some billing data from all the kind of major players for cloud providers. And there is a link there to a demo. Do we want to do this demo now? No.
That's over time. You've got the CO2 measurements over time from this is a fictitious cloud application that's costing $1,800 a day. So this is obviously something reasonably big. And then some emissions breakdowns based on which data centers they're using. So this is a multi-data center application and showing which data centers actually contributed more to that. And they've put it into a total tons of carbon dioxide equivalent, and also translated that into the number of flights. I think you can also do phones or trees. But yeah, if you're using cloud, that's just a useful tool you can use to give an estimate of what your carbon impact is.
Onto another tool, one that has been developed by some of us in the room. This was actually a winner of the Collaborations Workshop Hack Day from last year, which is CATS, which stands for the Climate Aware Task Scheduler. And this is a tool that was kind of a proof of concept from the Hack Day, and then we went on to develop it a bit further. Basically, adjusting when you're doing some compute to a time that has the lowest carbon intensity. It only works for the UK at the moment, but if there are other countries where we could hook it up to their power grid, if basically a country provided the same API or just generally information about the carbon intensity at a specific time and day as the national grid do here in the UK, then I guess CATS could run the same principle, at least could run. So ultimately, it was designed to be hooked up to a scheduler so that you can basically run whatever job process you want. And the CATS tool will schedule it to run at the time of least carbon intensity within the next, I think, few days. So the AT scheduler, AT command is the current scheduler to use. And there was some follow-on funding from this after the Hack Day to make the CATS tool work with Slurm clusters. So hopefully within the next maybe half year, that should be done. So that's nice. It's an example of a tool that has been developed through the SSI and with many other people. Oh God, sorry. Many people who were here at this collaborations workshop, or at least we're definitely at the last one. Another thing we'd like to highlight is relating to Kubernetes. There's this time shifting scheduler, or there's more than one. People have realized that this would be a good thing to do on the topic. So one that we have linked to is the Carbon Aware KEDA. Have I pronounced that right? Yeah.
I never know how to pronounce anything I read.
True. Let's say KEDA operator for Azure. So as well as temporal time approaches, it has spatial approaches for use with cloud providers. I don't know if it's just Azure or other ones, but
sure.
But yeah, that's a tool that you may be interested in if you use Kubernetes. Design patterns are also something to highlight. Did someone say time, or am I going crazy?
Looks like someone unmuted for a second.
Sorry. Okay. Sorry. Wasn't my own voice. Oh, terrifying. So we'll just quickly highlight. There's also some design patterns relating to green software. If you're not familiar with the term design patterns, I think it originated with some design patterns for object-oriented programming, so-called Gang of Four design patterns, and now is just a term used to, I guess, talk about. It might, in a general terms, it might just be a approach or a good practice. I'm not sure how broad the term is nowadays, but in this case, there's some guidance on particular good things you can do in the areas of AI, cloud, and the web. And they may be developing towards other areas as well. And there's some checklists on there which seem really useful for things that you can practically do. Actually, yeah, that'd be good. Just to highlight a few examples. So yeah, there's the 3 topics on the side: AI, cloud, and web. This is one example for.
Each of these down the side is a different design pattern. So we've got a few possible design patterns that they recommend for AI. So for instance, optimizing the size of your model. Basically, don't use models bigger than you expect. And for each of these, they have done some work around using the SCI score. Yeah. But most of these, I think, are really quite self-explanatory. They basically all say, don't use more resources than you have to. Let's look at some of the cloud ones as well as another example. So for instance, compressing data so you don't send as much data, and not using encryption where you don't need it, optimizing your CPU usage. And under the web ones, it's things like don't use animated GIFs because there's now better, more efficient formats to do that. Don't make your document object model too big because that can take more resources. Minify your web assets so you're not transmitting more data than you need. Optimize your image size. One pet peeve of mine is when people put 3,000 by 3,000 images in and then display them at 300 by 300 pixels. So they've transmitted 10 times more data than was needed.
Yeah, so there's some of the examples, but there's a lot on there to explore. And I personally hope they'll add a few more areas because I'm not sure AI, cloud, or web relate to the work I do, but I feel like there's probably other design patterns that could be created. So in short, only use what you need. As Colin said, a lot of those relate to not being wasteful. So only use what you need and reuse what you already have, which I think is a good general piece of advice in relation to green software. We've already mentioned it for kind of the hardware aspects and the embodied carbon as well. If you can make the best use of your work laptop before it gets sent on to wherever it goes afterwards, it's a good approach. Yes, as Colin has pointed out here, there's a lot of research use cases where this might not be as applicable as we hope. And maybe, yeah, we should write some of our own because I think it's a really good idea to have this actionable advice. So that's something to think about as maybe a suggestion for Hack Day discussion time. Best practice. I think this is my last slide, and then I'll hand over to Colin for some more practical demonstrations, hands-on aspects. But here we have a bit of a summary of various things that we've mentioned on reducing the impact of our software. So how can we make our software as green as possible? So firstly, try and quantify what you're actually using in terms of power. So if you can get access to data on the power, that's ideal. So we've mentioned plenty of tools that can help you to find this sort of thing out. If you're using the cloud, it might be slightly more difficult, but there should be some ways, such as this cloud carbon footprint tool, that you might be able to find out at least a decent estimate. SCI calculation, so this big equation we had here, which I think as Loic might have hinted at, is maybe quite simplified. It only accounts for, say, electricity, but that's still better than nothing. And
calculates.
potentially, yeah, might have slightly misinterpreted there, but this equation is a very good place to get a quantitative output, and you can use things like power profiling to help you to actually use the equation in practice. By applying some design patterns, green software design patterns, as we just covered, you might be able to mitigate some of the impact. You can verify with new measurements and new calculations. So if you do improve things, try and recalculate and then see how much better you've done. And actually sharing that information, publishing or just reporting somewhere the figures will help people to compare and contrast Because like, it's all very well knowing what you use, but actually the best thing is if you know what other people are using and you have a benchmark or a target to aim for instead of just figures that on their own aren't particularly helpful. Yeah, so that hopefully is a good summary of green software. We're now going to move on to a bit of a discussion and some live demonstrations, I believe. Yeah, so I'll hand over to Colin.
So on the back of that, we need to think about how we might apply this in the research software community. And I've got this HackMD link that I'll paste in the Slack and the Zoom chat, just thinking about what are the challenges and barriers for us doing this in research software? What are the actions we might take? Who are the stakeholders who would get involved? It's probably not just the research software developers and the RSEs. What opportunities do we have? What technologies might we employ? And what policies might we use to enforce this? So if we could take a few minutes to do that, and I'll put the HackMD up on the screen as well. Let me just stick it in Zoom chat. And that's not a good start. Someone says they've got a 403 forbidden. So do I. Do you have to sign in to HackMD? Can I sign in via GitHub? I'm just going to stop my share a minute while I sort this out. Are you logged into it? Saying that even when they're signed in without access, but then let's try and sort that out. Right, I think I've just changed the permissions. Can anyone verify if they can get to that? Okay, so I think it's sign in to edit, and anyone can view. And let me just bring that up on the screen share. So maybe we could take 5 minutes or so to put some thoughts down on this, and we could also have a discussion in the room and via Zoom if people want to say anything. And then we'll go on to the final bit with a demonstration of the Firefox Power Profiler. Yeah, I can see people editing it. That's good. Yeah, it's got an amendment of existing procurement policies to extend. Yeah. There's a question up there. Can we get a microphone up to you with Oscar? Got it.
Hey, what prevents people from just optimizing their software for energy consumption because when we've got such a high variability in your carbon intensity or carbon equivalent intensity, necessarily optimizing for energy consumption may not necessarily be the best course of action, because if you can get all of your work, all of your processing done during a time frame where the carbon intensity of the grid is incredibly low, would you not be better off using as much energy as possible?
And also not just in time, but in space as well. So let's say you have the choice of running on Jasmine, which is NERC's HPC facility that's located in the south of England, or on Archer, which is in Scotland. Generally, Scotland has a greener grid than the south of England. So maybe that's a good reason to go and run on Archer instead of Jasmine.
Thank you.
But of course, there's a lot of software you don't have any control over when it's run. So especially as the author of that software, you can't control that. So optimizing that still helps. I think one of the point actually with a lot of these green software patterns is they are built in mind of applications that have at least tens of thousands, if not millions of users. If you're writing, Facebook or the Google homepage or Twitter, the impact you can have is huge. Most of our software is probably not used by more than a few thousand people. I think a very successful research piece of software might be used by 10,000 people. And that maybe gives us a very different way of having to think about this. But on the other hand, a lot of our software is very computationally intensive compared with the software that, say, processes a tweet being sent on Twitter.
Point out if anyone needs any further bullet points, just add them in. Obviously, there's not. There could be more than 2 points per heading. That was obvious. Maybe add another bullet point if you're writing something, just so that people aren't writing on the same line. I'm not sure if FacMD works like the Google Doc.
Yeah, it is. Hopefully HackMD won't restrict us for having too many people on the document at once.
I thought it went well, but has it been extended? Are they going to do it again? Are there things that we could lobby other cloud providers to do something similar? Because that would be a instant way of reducing cooling costs.
I did see there's another data center provider who was putting them in swimming pools and trying to create a sort of win for local councils who wanted free heating for their swimming pools at the same time as running data centers.
Can we just check that the fish don't mind before we
Yeah.
see? Fish do rely on sound.
And they don't necessarily like overly warm water.
Yes. But if you scale it, then yeah.
They haven't done any environmental impact study. But surely building all the hardware, shipping it. Yeah, the pool one you mentioned on their website, they say, "Oh, we haven't figured out the environmental impact yet, but we're going to do that." Which is because you need to manufacture everything, ship it. You have to do the maintenance.
So maybe one for our policies discussion is do the environmental impact study first.
Yeah, that sounds like a good one. Oh yeah. James was saying for people online that it was used for Bitcoin mining, which is
okay. I thought it's been used for AI, but maybe that was a different project.
So much better.
I also do worry with that about you've also got to have the connectivity and the power connections going into those places, and that the grid power connections to a swimming pool may not be enough to power a data center. So you may then require grid upgrades. Okay, looks like we're getting a fairly healthy number of things in there. I'll give a couple more minutes and then we'll move on to, well, we'll go through what's in there and then we'll move on to the final demonstration. So yeah, I think we'll just read through and see if anyone wants to talk. Was that a comment coming through from online? Actually, I see there's some discussion in the chat as well online. I know that's old things. Sam, had you unmuted to ask a question? I guess not. Okay, so just looking through some of the things that we've come out with in the HackMD. So we've got about barriers, a lack of training, especially for self-taught programmers. Best practice challenges, yeah, conflicting needs. That was a big one, that developers don't have the time to do this sort of stuff sometimes. It's not easy to estimate cloud usage. And what's it, incentive mechanism in science where publications are mainly rewarded and acknowledged. One thing I did notice on the green algorithm site, there is a sort of suggestion of a citation or a statement that you can add to your paper saying how much carbon basically your paper took, with a sort of example text that you can add on. Opportunities. So lots of low-hanging fruit, easy savings in efficient coding, smart scheduling, yeah. Running training and outreach events like this and at RSECon. Yeah, I do wonder if we should rerun this event at RSECon perhaps. I'm also wondering if maybe there's a scope for building training materials where we actually have a multi-hour or multi-day even training course aimed at research software engineers. So stakeholders, PIs, funders, reporting requirements, researchers, scientists, RSE's technicians who are good at looking after maintaining hardware, and procurement teams and IT teams. Yeah, definitely. Technologies. Automatic compilers to make code efficient. That also implies you're using a compiled language. Clearer, more immediate demonstrations of energy cost, e.g. return energy used after running Python. We'll actually see some of that in a minute in the profiler. Does the task scheduler need to be linked to weather forecasting? Well, that's what CATS is. CATS is actually using the basically the weather forecast that's then been put into a energy carbon intensity forecast to work out when to run things. Validation frameworks. Oh, the highlight unknown answer patterns. Yeah, that would be really useful. Guidance energy use efficiency in different programming languages. Is compiling R into C worth the effort? Yeah, that's a good point. So policies, definitely amending existing procurement to allow for extended warranties. Yeah, and I also wonder if maybe we often see that cost is the driving factor, and that carbon emissions and reporting of scope 3 should be key things in our supply chains. Policies and scheduling using central HPCs. Yeah, software writing guidelines. Institutional funder sustainability reports. That would be an interesting one to report back on. Yeah, green computing and curriculums. There is a university in the Netherlands teaching undergraduate computer science who've started to try and embed sort of green computing in part of their curriculum and have several modules now on it that are freely available on GitHub. I'll try and dig out the URL for those later on. I think it's TU Delft, but I'm not certain. Lobbying for net zero electricity at data centers, yes. Finally, some actions we can take. Talk about this with colleagues. Awareness is the first step. Yep, definitely. That's a very good idea. Lobbying the journals and also working with anthropologists who are amazing at figuring out community practices, barriers to. Is there an anthropologist in the room who suggested that? Do you have any who you think would be particularly good at this? And maybe you could get involved and bring along next year or to RSCCon. Or... Okay. What's that?
So we have a question on the slider that we just noticed. So that's to Austin for drawing our attention to this.
So it says there's no power top equivalent for Mac or Windows. It would be interesting to see power consumption of general background processors by the OS. Even comparing something like editing and VS Code across different OSs would be informative. I'm sure there is an equivalent of power top on Windows at least. And actually, I'll show you now in the Firefox profiler that at least lets you profile web stuff. The way they actually got that to work for Mac was through a bit of an undocumented API. So just moving on then to the Firefox Power Profiler. This is part of a wider profiler that's built into Firefox. And I think most web browsers have some kind of profiler that will show you where the CPU is spending time when you run a web application, and also where it's doing network transfers and various other things. It will also screenshot at every stage, so you can actually see what was on the screen at any point. But recently they added power profiling that will actually tell you how much power the CPU, the GPU, on some systems, the RAM, and the overall system when using. It varies a bit, though, in what it reports between OSs and what different OSs can report. On Windows 11, it's got quite a reasonable reporting on most hardware. On Windows 10, there are a few specific machines that it worked with, which were mostly Microsoft Surface machines, but nothing else would give any reporting. On Mac, they found this undocumented feature, bug, possibly in the Apple Silicon that basically allowed them to extract the power information, but this was not something that Apple in any way helped with. On Linux, it uses this RAPL, the running average power level things from the Intel processors. There's an equivalent on ARM and AMD as well that PowerTop and Linux Perf are built upon. And you get yourself a nice little graph running with sort of time, along the x-axis, and then sort of power usage of various things going up the y-axis. And this can be done for the entire Firefox process, or it can be done for an individual tab. So if you want to set this up, you need to ensure that you have a fairly recent version of Firefox, a version 104 or newer. I think that came out late 2022. Close all your tabs. Unfortunately, if you are someone like me, where Firefox is your main browser and you have 50 tabs open, you run the risk of trying to profile them all. And I tried this the other day when I had that animated map of the renewable energy open, and that really, really crippled it because it was trying to capture those animated arrows moving, and that just froze my entire system for several minutes. If you then go to profiler.firefox.com, or you can install a little extension that gets you this profiler icon, then you can bring it up. Unfortunately, if you're on Linux, you need to do a little bit extra. There are some potential security issues with doing power profiling at very high resolutions, which I'll talk about in a minute. And to turn those protections off, you need to run a sysctl command that changes some of your kernel parameters. Or you can run Firefox as root. I think you're probably safer changing the kernel parameters than running Firefox as root. Also, if you're an Ubuntu user, the default version of Firefox comes through an Ubuntu snap package, which for some reason doesn't support this because it's kind of containerized. But if you install the deb version from Mozilla, it will work. Yeah, I'll just mention the side channel attacks and then I'll demo it. So the side channel attacks are where your computer leaks some information inadvertently through a side channel, such as how much power it's using. And if you can do very, very high resolution profiling of how much power the computer is using, you can infer about what the CPU is doing at the time. And this has been used to at least reduce the size of the sort of search space when trying to compromise cryptographic keys. And there are some universities who spend inordinate amounts of time trying to do these kind of attacks. Some also work on things like sounds and electromagnetic emissions that computers give off. And one mitigation that we can apply to this is to actually reduce the time resolution that is available. So the mitigation on Windows and Mac has actually been to reduce it to only reading once per millisecond. On Linux, they decided to restrict it to only the root user. And that's what that kernel parameters command I showed earlier did. And if you do want to run this and then you are super paranoid and want to turn it back on, there's the command in the slides to re-enable it. I've already done this on my laptop. So now let's try and profile a web page. And let me close all of my extra tabs and we'll, I guess, end up profiling Google Sheets. So I have this little profiler icon here. So it says record a performance profile. If I click on that, it's now gone blue and that is recording already. So let's go and do something like, I don't know, move to the next slide. And now I press that blue button again, it stops recording and it opens up the profile. And we now have along here, network bandwidth. At the top, we have screenshots so I can see what changed on the screen. And we'll see at some point I changed slide. And when I did the slide change, there is probably a bit of activity and there is some network activity where that data got transferred over the network. And for each of these positions, it's given us the number of watts for the instantaneous, sort of milliwatt hours for the range that's visible. So I think that's the entire x-axis. And it's also tried to give us a CO2 equivalent. This is only based on a global average number. So this is a very vague number. And that's actually using the CO2.js library. Yeah, there'll probably be a reasonable approximation. So I can do this for any web page, any web app. Another way I can open it is if I go to about:processes. For every process, if I mouse over the process, this little icon appears here. And if I click that, it will profile that process for 5 seconds. So I'll get a 5-second profile out for that. If I want to do it longer, then I have to do it the other way that I just showed by pressing the thing in the toolbar. I think I've shown everything there. You can also share these. I think they actually get uploaded to Firefox automatically, that profile.firefox.com site. So there is some privacy concerns if you're viewing anything particularly sensitive, but you can also share them with other users. And one that I found particularly interesting was from a talk at FOSDEM, the Free and Open Source Developers European Meeting. It's a really big open source conference every year. This one is profiling the flashing cursor. And we can see that the power spikes every time the cursor flashes. And you can actually measure it in microwatts of extra power used to flash the cursor on and off. The author of this talk has also taken this to the next level. He has gone and installed power monitoring devices all around his house and has started power profiling every piece of equipment in his house, and has actually managed to export that data into a format that Firefox Profiler will import. So now he's got graphs that will view what is going on in his house, and I think he's actually shared one here. So yeah, here he's got things like his grid import, his office, upstairs, freezer, laundry, boiler, a milk pump for a baby, and he can measure how much his entire house is using and has gained some interesting insights into that. So he did a talk at FOSDEM on this. And one of the things he found, for instance, was that his microwave, when it's defrosting, pulses on and off. And he has solar panels in his house. And in theory, the average power of the microwave is less than that of the solar panels. But the instantaneous power, while you're pulsing that on and off to do the defrost, exceeds that. So you're actually not entirely using the solar panels and doing some grid import to defrost bread in the microwave. And if you want to see either of those talks, the links are there. I will share the slides later. And just finally, some interesting and useful resources that you might want to follow. So a lot of the material in the background for this has come from a group called the Green Software Foundation, who are the ones who've built these sets of green software patterns. They have a podcast, they call it Environment Variables. That is very good about these sort of issues if you're interested in this more. We've mentioned several times now the Green Algorithms Calculator, and there's an HPC specific version of it. There's also some training materials that are out there. Again, these are not research software specific, but there are some Linux Foundation Green Software Practitioner courses. Microsoft have some principles of sustainable software engineering. And there's also much more generically the Carbon Literacy Project, who have some general stuff about understanding just climate change as a whole. I also want to promote that LOIC has launched today, I suppose, the Environmental Sustainable Computational Science Community, where we can all gather and hopefully discuss this sort of thing more. And there's also Michael Bain's Green Compute, which has a whole load of useful resources for this. And I think that is everything we've got. Are there any final questions or comments? Oh, are we? Oh, sorry.
So I was late, so I don't know if this was talked about earlier. And just a kind of vague thought that is there. So a lot of like the web frameworks and things now, very JavaScript heavy. And that's quite a lot of extra content that is being delivered even via CDNs across the network and across the internet. And also if people are using things like Node.js or compiler, things like that, and they're being built every time you push to GitHub via actions and things, what is the impact of those? So there were two impacts. There were, yeah, these websites that have got big CDN based JavaScript libraries and the compilation of
I think you've got
websites.
multiple impacts there, because you've got the network transfer times, you've got the running of the CDN, and you've got the impact on the computers that actually run that JavaScript as the client side.
So are they more efficient than the alternatives or not?
What do you consider the alternative to be? Static HTML?
Well, yeah, indeed. Well, yeah, if you're going to go completely basic, yeah.
One thought I've had recently is that actually I've seen a lot of web pages now start to send a JSON payload with some data and a very large amount of JavaScript that then renders that. And that is certainly more efficient for the web server than rendering it to static HTML and then sending you the HTML. So there may be an argument there, and maybe they're just transferring the emissions to someone else.
But are web servers more efficient than laptops at rendering? So if your laptop is doing it, that means your laptop is rendering it.
I'm tempted to say probably not, but I'm not certain on that. And I want to go and profile it and see what the answers look like.
Okay.
Yeah, I think we have overrun into break. Sorry, I hadn't realized. So maybe we could go and have further discussions during the break.
Yeah, so you can wrap up, or do you want to wrap up? Or... I don't want to. Thank you very much for our speakers. Thanks everyone for attending. There'll be a break for about 20 minutes and then coming back to the tiered lecture theatre here. But please give a round of applause for the wonderful.